Hey space explorers, and welcome back to the channel. Today we're venturing out to a truly fascinating world, a tiny giant nestled in the vast expanse between Mars and Jupiter. I'm talking about Ceres, the largest object in the asteroid belt and a dwarf planet brimming with secrets. Forget what you think you know about asteroids. Ceres isn't just another chunk of rock. It's a complex, dynamic world, and its most captivating feature, those mysterious bright spots that gleam like diamonds on a dusty canvas. For years, these enigmatic lights baffled scientists, sparking theories from alien cities to giant ice volcanoes. What are they really? And what do they tell us about the hidden world lurking beneath Ceres's cratered surface? Get ready, because we're about to dive deep into the icy mysteries of this incredible dwarf planet. So, what exactly is Ceres? Discovered way back in 1801 by Giuseppe Piazzi, it was initially hailed as a new planet. As more and more objects were found in the same region, it was reclassified as an asteroid, the biggest one we knew of. But the story didn't end there. In 2006, with the official definition of a planet, Ceres got another promotion, this time to dwarf planet status, joining the ranks of Pluto. This classification is key. To be a dwarf planet, an object has to be massive enough for its own gravity to pull it into a nearly round shape, a process called hydrostatic equilibrium. This tells us Ceres isn't just a lumpy potato-shaped rock. It has enough mass and internal action to have formed into a sphere. It's about 590 miles, or 950 kilometers, in diameter. That might sound small compared to Earth, but it makes up a full third of the total mass of the entire asteroid belt. It's the king of its domain. The real game-changer in our understanding of Ceres came with the arrival of NASA's Dawn spacecraft in 2015. For the first time, we weren't just looking at a blurry dot through a telescope. We were seeing a detailed, crater-covered world up close, and that's when those bright spots truly captured the world's imagination. Before Dawn, even the Hubble Space Telescope could only see a single, blurry bright patch. But Dawn's high-resolution cameras revealed not one, but hundreds of these features scattered across the surface. The most famous and brightest of them all are located inside a 57-mile-wide crater named Occator. These spots, named Cerealia Facula and Venalia Faculae, are so bright they reflect sunlight like freshly fallen snow, standing in stark contrast to the dark, dusty terrain around them. The initial images were so stunning and so strange, the scientific community was buzzing with theories. So, what are these dazzling lights? The initial hypothesis was ice. Ceres is far from the sun, and it's cold enough for water ice to exist. Maybe impacts from other asteroids had excavated a layer of pure ice from just beneath the surface. This was a plausible idea, but it didn't quite fit all the evidence. If it were just exposed ice, it should have sublimated, turning directly into gas and disappearing into space relatively quickly. But these features seem to be persistent. 甚至可能地质上年轻, the mystery deepened. Could it be something else? The data from Dawn's instruments, particularly its spectrometer which analyzes the composition of light, gave us the crucial clue. It turns out, these bright spots are not primarily water ice. They are vast deposits of salt, specifically a type of salt called sodium carbonate. On Earth, sodium carbonate is found in hydrothermal environments, like the mineral deposits left behind by hot springs. Finding it on Ceres was a bombshell. This discovery paints a picture of a geologically active world, or at least a world that was active in the very recent past. The leading theory now is that these salts are the remnants of a briny liquid that erupted from below. Imagine a deep, subsurface reservoir of salty water. When an asteroid slams into Ceres, creating a crater like Occator, it fractures the crust. This allows the pressurized, briny liquid from below to well up to the surface. Once exposed to the vacuum of space, the water in the brine quickly boils away and freezes, leaving behind the highly reflective salt deposits. It's like a salty, slushy volcano. This process, known as cryovolcanism, ice volcanism, suggests that Ceres has, or recently had, liquid water sloshing around under its rocky, icy shell. The fact that the deposits in Occator Crater look so fresh and bright suggests they might have been formed as recently as a couple of million years ago, a mere blink of an eye in cosmic terms. This leads us to the most exciting question of all. Could Ceres have a subsurface ocean? The evidence is piling up. Besides the salt deposits, Dawn's gravity measurements revealed something intriguing about Ceres' interior. Its density is lower than expected for a purely rocky body, suggesting a significant portion of its mass is made of lighter materials, like water ice. Models based on this data suggest that Ceres might have a differentiated interior, a solid core, a mantle rich in water ice, and a thin, dusty outer crust. It's possible that a layer of this mantle, perhaps enriched with salts that act as an antifreeze, could remain liquid. This wouldn't be a global ocean like the one suspected on Europa or Enceladus, but more likely a deep, briny reservoir, or a mushy, partially liquid layer. The energy needed to keep this water liquid could come from the decay of radioactive elements in its core, a process that has been happening since Ceres first formed. So you have liquid water, you have a source of energy, and you have complex chemistry, as evidenced by the carbonates and other minerals found on the surface. These are the three key ingredients for life as we know it. Does this mean there's life on Ceres? We absolutely don't know. But it does make Ceres an incredibly compelling target in the search for habitable environments in our solar system. It suggests that the conditions for life might not be confined to the moons of giant planets, but could also exist on smaller, more isolated worlds. Ceres is showing us that the habitable zone might be much broader than we once thought. Any potential life would be microbial, of course, living in that dark, briny underworld. But the very possibility is tantalizing. It forces us to reconsider what a living world could look like. Beyond the bright spots and the potential for a subsurface ocean, Ceres is a world of other wonders. It's covered in craters, but with a strange twist. It lacks the truly giant impact basins you'd expect to see on a body that's been battered in the asteroid belt for 4.5 billion years. One theory is that its icy, somewhat soft interior has allowed the crust to relax over geological time, slowly erasing the evidence of the largest, most ancient impacts. It's like the planet is slowly healing its own scars. There's also a single, massive, lonely mountain named Ahuna Mons. It's a cryovolcano, a mountain built from repeated eruptions of icy slush. It stands about 2.5 miles, or 4 kilometers, high, and looks completely out of place on the otherwise gently rolling plains. It's a monumental testament to the internal forces that have shaped this dwarf planet, a frozen volcano that serves as a smoking gun for Ceres' active past. The Dawn mission officially ended in 2018, when the spacecraft ran out of the hydrazine fuel it needed to keep its antennas pointed toward Earth. But it was placed in a stable, long-term orbit around Ceres, where it will remain as a silent, artificial moon for decades, if not centuries. The treasure trove of data it sent back is still being analyzed by scientists, and we are learning new things about Ceres all the time. For instance, recent studies of the Occator Crater deposits suggest the brines that sourced them came from a deep reservoir, roughly 25 miles or 40 kilometers down. This deep source strengthens the case for a long-lasting, extensive liquid environment. What's next for Ceres? While there are no funded missions on the books just yet, scientists are already dreaming of what a follow-up could achieve. A lander, for example, could drill into the bright salt deposits to directly analyze their composition and search for complex organic molecules. A future orbiter with more advanced radar could map the subsurface in detail, confirming the extent of any liquid layer. Ceres has fundamentally changed our view of the asteroid belt. It's not just a graveyard of cosmic debris. It's a dynamic, evolving place, home to a world that might hold the key ingredients for life. It's a bridge between the rocky inner planets and the icy outer worlds. From a blurry light in a telescope to a complex world of salty ice volcanoes and a potential subsurface ocean, Ceres has proven to be one of the most surprising and exciting destinations in our solar system. It reminds us that there are still incredible mysteries waiting to be solved, right in our own cosmic backyard. What other secrets does this tiny world hold? Only future exploration will tell. Thanks for joining me on this journey to the incredible dwarf planet Ceres. It's a testament to how even the smallest worlds can hold the biggest surprises. What do you find most fascinating about Ceres? Let me know down in the comments. And if you enjoyed this cosmic adventure, be sure to hit that like button and subscribe for more deep dives into the wonders of our universe. Until next time, keep looking up.